Right. Assalamualaikum. Okay, today we'll do the briefing on lab number 6, okay, or laboratory number 6. Please be ready with your manual. Okay, what is laboratory 6 all about? It's saponification value and acid value. So the experiment focusing on the chapter of lipid in our lectures, okay? So all of you will learn a lipid after the break exam next week, okay? So which means at the week number 8, we are going to enter lipid, inshallah. Okay, what is saponification value? For that, we have an introduction. Triglyceride is what we call fat, composed of 3 fatty acid linked to glycerol by the fatty acyl ester. So the bond will be oxygen, CO, and R. R represent the side chain. So what we mean of side chain for triglyceride or lipid is a fatty acids. So how long the chain will be, okay, is depending on the numbers of carbons. The fatty acids may be saturated or non-double bond or unsaturated. The liquid triglycerol are oils, so mostly on unsaturated part. Okay, for example, it comes from plants, okay, peanuts, okay, and the solid triglyceride are fats come from the animals, right? So for the experiment, by heating the triglyceride in the aqueous potassium hydroxide or KOH, the fatty acyl ester can be cleaved off or hydrolyzed or hydrolysis, leaving behind glycerol and the potassium salts of fatty acids. So the process is what we call saponifications, or in other words, will be soap formations. Since the potassium salts of the fatty acid or fatty are in effect soaps, right? So why we need the numbers of saponification is as an indicator of fatty acid chain length in the triglyceride. So triglyceride is one of the fat. The value is simply a measurement of the milliliter of potassium hydroxide required to complete the hydrolysis of 1 gram of fat or oils. Okay. Triglyceride containing long fatty acids will have the lower saponification number of values. So it's vice versa. Kalau kita ada shorter fatty acid, nilai dia akan jadi lebih tinggi. Alright. So I have to put inside the formula. So saponification value equal with the 56.1. So this value is intact. Ataupun memang kekal. Okay, from this formulation. And then you have to, the change will be N. A divide A. The A will tolak dengan B, right? And then divided by W. So from the below, where A is what? A is the milliliter of acid hydrochloric which is required for the titration of a blank. So blanks mean no sample inside, right? B, a milliliter of HCl or acid hydrochlorics which is required for titration of the samples. Okay, so put here A and B. So what about W? W is a weight of sample in the gram. So kita akan tengok berapa berat yang kita akan pakai. So last one will be N. N is a normality of the acid hydrochloric, which means the solution they used to titrate, right? So quickly we go for the methods. Okay, number 1, select one of the following, butter or margarine. Okay, what's the difference between butter and margarine? So butter mostly coming from animal, for example, margarine mostly from the plants. Okay. So the place 2 gram of sample triglyceride. So now you have a W in the 250 ml round bottle flask. So round bottle flask can be contained with the 250 ml. So dalam round bottle flask tu kita boleh isi sebanyak 250 ml. Okay. So dalam tu kita kena letak dissolve in 25 ml of 1N alcoholic potassium hydroxide. Okay, this one we have found another number which is the N. Okay. So from here, the W is 2 gram, N will be 1. Okay. And then you have to set up the reflux condenser. Okay. So After finish the briefing, I will show you saponification methods. So you can see what is the reflux condenser all about, okay, from that video. And I will record it for you. On each flask and place on the heating mantle for 30 minutes. The hydrolysis will occur during these periods. Okay. So now you have to allow the flask to be cool after 30 minutes heating. Okay. Add 1 ml of indicator solutions. So make sure you put indicator which are 1% of volume per volume phenolphthalein. So this is our indicator. Okay, indicator, untuk apa kita letak indicator? To show the changes of the color. Okay, either we have to maintain the color changes. Alright. So mostly phenolphthalein, kalau kita masukkan dalam sampel, dia akan tukar menjadi warna pink, for example. Alright. And titrate with 1 molar of HCl. Okay. Set up a second system as a control with a 25 ml of 1 and ataupun normality alcoholic potassium hydroxide. And then the result, you have to calculate the saponification value for the tested samples. Okay, please use the formula above. Right? And then go for the acid value. So why we need acid value is a measurement of extent to which the glyceride in the oil have been decomposed by the lipid or other actions and accelerate by heat and light. So determination is often used as a general indicator of the condition and edibility of the oils. So mostly kita gunakan untuk kita check kita punya fat ataupun kita punya lipid ataupun lemak dalam keadaan yang okey ke tak. Kalau tak, okay, kalau awak dah lama letak luar, macam for example awak punya mentega dan sebagainya, dia akan memberikan bau yang tengik. That words we call it rancidity. So bau itu disebabkan kerana kehadiran banyak asid di dalam kita punya fat. Why? Because of the decomposed by lipids or other action which is accelerated by the heat or light. Okay. So the acid value is defined as the number of milligram of potassium hydroxide which is required to neutralize the acid in 1 gram of fatty materials. Okay. So the formula will be like this: acid value equal to 56.1. Okay, times T. T is what? T is titrate. Okay. So this titrate will be in mil. N is our normality of potassium hydroxide solutions. And divided with the weights. Okay. So please bear in mind, acid value and saponification don't have any units of SI. Okay, they tak ada unit. So how are you doing the acid value? First of all, you have to find the weight, W. So we take about 10 grams of old butter. Okay, there you find the W there. In the 250 ml Erlenmeyer flask. So Erlenmeyer flask, you can put S maximum 250 ml. Okay, itu masuk dekat sini ayat ni. So you have to dissolve what? 50 ml of neutral alcohol. So 50 ml neutral alcohol plus with the 10 gram of old butter. And then you have to place the Erlenmeyer flask in the boiling water for 5 minutes. Okay. The hydrolysis will occur during this period. Again, number 3, you have to put the indicator solution. So the same as the saponification, acid value also using a phenolphthalein. Volume per volume, 1%. While shaking, okay, so you have to titrate immediately. And while shaking, so the difference between method acid value and saponification, saponification you have to warm it first, ataupun biar sekejap. Jangan terus kita titrate. Beza dengan acid value. Saponification awak kena biarkan dia sejuk sekejap, suam dekat tangan awak tu, bawa awak buat titrate. Okay. Yang kedua, awak punya titration solution. Okay, for this acid value, you have to put 0.1 N. So you have found the value for N in these methods, which is 0.1 N. Alcoholic co ataupun potassium hydroxide until the pink color persists for at least 30 seconds. So the difference between saponification and acid value, the result, okay. So in acid value, you have to find the from clear to pink. Tapi untuk saponification, awak akan dapat pink, and you have to change it into clear, right? That's the difference between saponification and acid values. Okay, last one, you have to set up a second system using new butter as the samples. Okay, so two type of sample we're using in the acid value. Number one will be all butter. Number two with new butter with the same weights. Okay, and then done the process of calculations. Okay. Is there a question before we enter our notes?
No. No, sir.
All right. Okay, kalau tak ada, kita sambung the notes behind the experiment, all right? Okay, this is the what we call saponification acid value, all about, all right? The info, the notes about the saponification. Since you don't have the time to do the practical, so this is the best way to show you how the saponification acid value method were done. Okay, we go for the saponification value first. Okay. All right, so this is our lipid or fat. So the fat will contain, one part is what we call glycerol. COC is our ester bond. This is our fatty acids. Okay, once you've done the process of hydrolysis by adding the potassium hydroxide, you will get two components. Number one will be glycerol, actually three glycerol or triplet, and then you get a triplet soap. Why we call it soap? Because you put it the potassium ion here. Okay, so R represent the fatty acids. So fatty acids again for lipid is a side chain depending on numbers of carbon. Each of fatty acid have a special number of carbon. For example, stearic acid, let's say have a 18 ataupun 18 carbons. Okay. Oleic acid have 34, for example, right? Okay, saponification is hydrolysis of fats of oil under basic condition to produce glycerol and the salts of the corresponding fatty acid. So you get this one, okay, this will be the salt of potassium. In other words, they are calling soap making. So why is very important in saponification value? The industry is very keen to know ataupun penting sebab apa? He will know amount of free fatty acid presence inside the product. Okay, since this will determine in the large measurement of refining loss. Okay, contoh macam kita nak buat biodiesel, for example, so berapa banyak fatty acid yang kita perlu digunakan ataupun hilang dalam proses pembuatan biodiesel minyak tu. That's why we're using a saponification value. Okay, the amount of free fatty acid is estimated by determining of the quantity of alkali. Since we put the potassium ion, potassium dioxide, or salts, that way you get a soap. Okay, that must be added to neutralize the fatty acids. Okay, so fat combined with the alkali, you can get the soap. This is done by warming a known amount of fat with a strong aqueous caustic soda solution. Okay, aqueous caustic soda solution. So there are two types of soda solution. For example, potassium hydroxide or sodium hydroxide, which convert the free fatty acid into the soap. Okay, this soap is then removed, and the amount of fat remaining is then determined by the titrating with the strong acids. The loss is estimated by subtracting this amount from the amount of fat originally taken from the test. That's the meaning of saponification all about. So you find the saponification number. What's the meaning of saponification number? The number of milligram of potassium hydroxide, which is required to neutralize the fatty acid resulting from the complete hydrolysis of 1 gram of fat. From this information, you will get what? Number one, the longer of carbon change, the less acid elaborated per gram of the fat hydrolyzed. Number two, you can consider the measurement of average molecular weights or chain length of all the fatty acid present. Yang pertama, kita boleh tengok berapa panjang carbon chain dia. Yang kedua, kita boleh ukur keberatan lemak di dalam satu produk. Okay. That's meaning of saponification numbers. Okay, so the tips, if the change is long, the number of saponification will be low. Okay, if the chain is short, the number of saponification will be high. Right? Okay, continue. Right? For saponification value, the long chain fatty acid found in fat will be the low saponification value. Saya ulang tadi. Okay. Why? Because the fatty acid have a relatively few numbers of carboxylic functioning group. Okay, carboxylic is one of the yang ada dekat kita punya fatty acids. Per unit mass of the fat, therefore high molecular weights will be collected. Okay. So dekat mana ada carboxylic group? Carboxylic group berada dekat pada kita punya kumpulan tadi tu. Sini. This one we have a lot of carboxylic group. We have a saponification value videos. You can see. Okay, I already upload inside the course content. You can see the video, right? Okay, number two is acid value. So define the word acid value, the number of milligram of potassium hydroxide necessary to neutralize the fatty acid in the 1 gram of samples. Right? So as all fats recidify ataupun recidity ataupun tengik bahasa Melayu, okay, kenapa berlaku? Why happen? What happened? Because all triglyceride of fat are converted into fatty acid and glycerol, causing in the increase in the acid number. Okay, keadaan bau tengik ataupun tengik acidity tu disebabkan kerana kehadiran banyak asid di dalam kita punya butter, for example, old butter, for example. New butter tak ada, bau dia boleh tahu, okay, dan rasa dia lebih masam. High amount of free fatty acid in sample of oil or fat indicate many of triglyceride have been hydrolyzed. Okay, so let's say awak ada produk makanan, awak nak tengok kuantiti lemak dalam makanan tersebut, awak kena check, okay, pakai acid value, boleh. Tahap keasidan makanan awak, kita gunakan acid value. Such reaction occur by the action of lipase enzyme. So kenapa berlaku? Okay, pertama adalah enzim lipase ada di dalam produk kita. So once you collect the fat from the for example plant ataupun for example of animals, they may be occurs with the enzyme inside there. So this enzyme akan aktif bila ada suhu tertentu, right? Yang kedua, because of the high temperature, relative humidity or tissue damage. So why you need to know about acid value is to show ataupun mengetahui processing and storage condition certain food or product from industries. So bila kita tahu bahawa storage mungkin rosak, makanan itu rosak sebabkan kerana storage. Yang kedua mungkin kerana processing, right? That's meaning of acid value all about. Okay, there are video for you to see. Okay, there are two video, number 1 and number 2. You can see on your own. Okay. Okay. Is there any question before we continue for our videos? Okay. Ada soalan? Okay, bila ongoing briefing ni, so bila saya dah masukkan video, so all of you can log out, okay, boleh log out. Dan saya akan rakamkan video. This one is your senior video. So boleh tengok dalam YouTube nanti bila saya masuk ke dalam my YouTube, right? So is there any question before I start open the video? Ada soalan tak sebelum saya buka video mengenai saponification methods?
Sir,
Yep.
saya nak tanya.
Okay.
Yang saya cakap tadi tu, kalau kita nak tengok makanan kita tu, macam kita nak check quantity acid value dalam makanan tu.
Betul.
Macam mana kita nak apply, saya tak faham macam mana kita nak apply acid value ni untuk check makanan tu.
So untuk makanan tu bergantung kepada makanan apa yang orang buat. Contohnya makan yang banyak lemak, mostly oil ataupun banyak letak butter banyak, contohnya macam makan apa-apa yang dalam awak gunakan dalam proses tersebut, kita boleh detect bahan bersukan lemak tu macam mana keadaan dia. Adakah dia dah rosak atau tak. Kalau pakai acid value ni ataupun saponification. Saponification kita nak tahu dia punya apa tu, apa jenis lemak, panjang lemak dia punya strand tu. Acid value nak tengok keadaan lemak tu dah berapa lama. Faham tak?
Faham, sir.
So maknanya kalau katakan awak buat kek for example kan, so ambil sampel kek tu tapi jangan banyak, mungkin 1 gram, yang lebih daripada berapa gram yang kita buat tu, lepas tu awak panaskan, lepas tu awak jalankan proses application ataupun acid value. So nilai yang awak dapat, awak boleh tahu berapa banyak lemak, jenis lemak yang ada kat situ, dan juga berapa lama dah sampel awak tu terbiar ataupun tak disimpan. Faham tak?
Oh, faham, sir.
Okay. So dalam eksperimen ni merujuk pada lipid, tapi kalau awak ada sampel, awak boleh guna juga untuk eksperimen ni. Okay.
Okay, thank
Boleh.
you, sir.
Tapi tak banyak lah. Katakan makanan awak 10 kilo, 50 kilo, ambil separuh daripada situ. Melalui metod kita buat. Boleh?
Ambil 25 kilo lah, sir.
Kalau tak, maksud saya apa tu, kalau kita buat eksperimen yang pertama tu, berapa kilo kita pakai? The first tu 2 gram. Dia tak banyak, 2 gram je, tak banyak. Sebab kiraan 2 gram tu. So nanti kita andaikan berapa banyak. Sebab dia boleh detect 1 gram je. Tapi awak boleh gunakan bersamaan dengan 25 kilogram dan sebagainya lah. Faham?
Faham,
Kita
sir.
samakan. Okay? Sebab yang boleh detect ni 1 gram je. Tapi kita boleh samakan dengan kita punya sampel. Boleh?
Boleh, sir.
Alright, ada soalan lain sebelum saya mula buka video ni?
Kini, sir, kalau pengiraan dia tu sama je lah kan? Saponification dengan SEQ
yang
tu.
perkiraan yang ada ni adalah untuk 1 gram. So bila awak pakai 25 kilo, awak darab lah nanti berapa bilangan unit tu. Tapi tak ada unit Boleh.
Okay, boleh. Thank you, sir.
Alright. Is there any question left?
Tak ada, sir.
Alright, kalau tak ada saya mulakan buka video. So siapa yang nak log out boleh. Tapi saya akan bagi soalan post dia dekat dalam ni, post lab questions. So boleh jawab nanti bersama dengan. So jangan lupa jawab dalam discussion dekat e-future untuk attendance. Right, thank you very much.
In the experiment, the apparatus that we need are round bottom flask, weighing bowl, filter funnel, 25 ml measuring cylinder, 10 ml measuring cylinder, conical flask, burette, spatula, And lastly, retard stand.
Materials that we use are hydrochloric acid, phenolphthalein, alcohol, potassium hydroxide, and new butter.
Firstly, turn on the weighing balance. Turn on the weighing balance and weigh 2 grams of butter. Transfer 2 grams of butter into 250 ml round bottom flask. Dissolve 2 grams of butter with 25 ml of alcoholic potassium hydroxide. Set up a reflux condenser and place the round bottom flask on heating metal for 30 minutes. Switch on the reflux condenser and set the temperature within 60 to 70 degrees Celsius. Remove the round bottom flask from the heating mantle and allow it to cool. Once it has cooled, add 1 ml of phenolphthalein into the round bottom flask and start to titrate with hydrochloric acid. Insert 1 molarity of hydrochloric acid into burette for the preparation of titration process. Stop the titration process until you reach its end point, which it turns from purple color to yellowish. Set up a second system as a control with 25 ml of 1 normality alcoholic potassium hydroxide. Titrate the solution with 1 molarity of hydrochloric acid and wait until it turns colorless.
The end of experiment, we need to calculate the saponification equation. The formula for saponification value at 56.1 times by n is normality of HCl times by A minus B, which is ml of HCl required with nitrate blank and ml of HCl required with nitrate sample, and divided by weight. So we got this, where normality is 1 normality, A is 25.5 and minus 17.5 divided by 2.00031. So the ratio we got is 2 to 4.053.